Hi, you're welcome to Explore Insight. In this video, I'll be taking on the lab 9.2.9, which is to examine the ARP table. Here we have the addressing table for the switches and down to the interface, MAC addresses, and the switch interfaces. Also, we have the objective, which will be of three parts. The first is to examine an ARP request. The second is to examine a switch MAC address table. And the third is to examine the ARP process in remote communication. Now, to further proceed, we'll be looking at the background. Remember, this activity is optimized for viewing PDUs. The devices are already configured. You will get PDU information in simulation mode and answer a series of questions about the data you collect. I will be doing these questions together, so don't panic about it. Now, the next thing we have is to take on with every instruction given to us in these three parts. So if you're just joining this video for the first time or joining this channel for the first time, don't forget to like, to subscribe, and also to share. Don't forget to also hit the notification bell so that you get notified when I upload a new content. So let's get back to what we expected to do in this lab exercise. So the first one is to examine an ARP request. Now, when you're talking about ARP, that's the Address Resolution Protocol. So we want to examine its request. The first step we have here is to generate ARP requests by pinging 172.16.31.3 from 172.16.31.2. How do we do that? We have to get onto our Cisco packet tracer, and in the topology, you can see that we have 2 routers, 2 switches, an access point, 2 laptops, and 3 PCs. The first thing we need to do here in step 1 is to first of all check which IP address has 172.16.31.3 and that of .2. So you could see that we have this IP address here. Now take note, it said we are going to ping 172.16.31.3 from .2. So we will come to .2, click here, and go to desktop. From desktop, we'll go to the command prompt, which is what is rightly written here. Now, what do we do? So we click on .2, open the command prompt, enter the ARP.d command to clear the ARP table. But before we proceed, let me make a few steps before we clear. So the first thing we have to do is to ping 172.16.31.3. Now, when we ping that, we are going to check the packet information. So we can see that sent for, received for, 0 loss. The next thing we need to do is let's check this ARP table first before we delete. So for us to check, we have ARP space -A. So this tells us what we have here. So it tells us the internet address, the physical address, and the type of that IP address. Now, the next thing we need to do is to delete, which we have here in step 1B. How do we delete? We say ARP, then -D. Now, if you do that and go back to check the ARP table, you'll find out that you just need to use your forward arrow to do that. You don't need to type any further. So once you do that, you notice that we don't have any entry here, no entries found. Unlike when we checked before, we got the entry, but in this case, it says no entry found. So what does that tell you? It means that whenever you clear, it means you're removing any ARP table found initially there. So let's go to 1C. 1C says enter the simulation mode and enter the command ping 172.16.31.3. Then we are going to realize that 2 PDUs will be generated. The ping command cannot complete the ICMP packet without knowing the MAC address of the destination, So the computer sends an ARP broadcast frame to find the MAC address of the destination. Now, let's proceed with what we have in 1C. So in 1C, you click on the simulation. When you click on the simulation, repeat the ping you've done initially. So we'll come here and ping 172.16.31.3. So once we ping that, we are going to see two PDUs as rightly stated. So let me keep this by the side. So you have two PDUs. Now let me give a little explanation about this PDU a bit. Now you can see that in this PDU, the blue one, I don't know if you see that as brown on your own end. One of it is the ICMP and the other is the ARP. So this green one is the ARP and the blue is the ICMP. So just hover around the PDU and try to get what kind of protocol you can see there. Okay, so now the PDU command cannot complete the ICMP packets without knowing the MAC address. So that tells us that our ARP PDU will be used to find the MAC address of the destination by sending a broadcast frame. So all we need to do is now to click forward once. And once we click here, you can see this forward. The PDU will move to switch 1. So let's take a look at that. Another thing you notice that the ARP PDUs move switch 1. It will move to switch 1. This one will move to switch 1. But this other one will disappear, which is the ICMP PDU will disappear, waiting for the ARP reply because there is no MAC address yet. So we are going to then open the PDU and record the destination MAC address. All what I'm talking about is in step 1D. So let's click forward. Now you can see that now we just have one PDU rather than two, and that's the ARP. ICMP has disappeared. Okay, so let's click the PDU, open the PDU, and then record the destination MAC address. Now, if you have watched my previous videos, I've taken time to explain these in layers and out layers. But if you're just joining for the first time, please, I'll do what to try to explain that. If you feel you're not interested in the information for this, you can just move forward the video. Okay, so let's talk about the MAC address. Okay, for this MAC address, it is always found in layer 2, while for the IP address, it is found in layer 3. The layer 1 talks about the physical layer of the OSI model. So this part is talking about OSI model. Now you can see that this is our source address and this is our destination address. The FFF.FFF.FFF. So it's asking record the PDU and record the destination MAC address. So our destination MAC address will be FFFF.FFFF.FFFF, which you're going to see on my booklet. Okay, so the question we have now is this address listed in the table above? Is it listed in the table above? So you've been wondering which table. Remember when we started, I talked about the addressing table. So can we get any destination address like FFF all over here? No, we don't have that. So this is why I wrote that no, because we can't find FFFF as a destination MAC address on the table. Okay, so let's move to the next one. It says click forward to move the PDU to the next device. And you need to find out how many copies of the PDU did switch 1 make. Okay, so all we need to do is come back, go to your capture, click forward. Now it asks how many PDUs were sent forth. Now you can see we have 1, 2, 3. So we have 3 PDUs. Okay, so this is why you have the answer 3 PDUs. Now, the next question we have here is, what is the IP address of the device that accepted the PDUs? We want to find out the IP address. It's easy to find. You can see that 172.16.31.3 actually has the right PDUs. The other one we just marked with red cross. So let's go to the next question. So our next question, 1F, says, open the PDU and examine the layer 2. What happened to the source and destination MAC address? Okay, so we are going to open the PDU for this. That means 172.16.31.3. And then we are going to examine the layer 2. So if you look at the layer 2, what can you see? Okay, so to better understand that, we need to find out what happened to the source and the MAC address. Now, you notice that the source MAC address changed. So it became the destination MAC address. And also the FFFFFF, you can see, turned into the MAC address of 172.16.31.3 as 0060.7036.2849. So you can see this information all over here. So you can see that here. Okay, so take a look at this part. You can see the information, how the source MAC address changed to the destination MAC address, and how the FFF turned into the 172.16.31 changed to 006070362849. So let's go to 1G. Now in 1G, it says that we have to click forward until the PDU returns to 172.16.31.2. And the next question is, we need to find out how many copies of the PDU did the switch make during the ARP reply. Okay, so let's come here and click forward. Let's have a look here and see what happens. So I'll click until it gets to .2. Click again. Now, when it gets to .2, how many copies does it get as a reply? So you realize that it's going to get 1 copy of the PDU. Okay, so this is why I have written 1. Let's go to step 3. Okay, so let's go to step 2. Step 2 says, examine the ARP table. So note that the ICMP packet reappears. Open the PDU and examine the MAC addresses. So the question we have here is, do the MAC addresses of the source and destination align with their IP addresses? Now, if you notice here, while we have the PDU, we also have the ICMP packet. So at this point, it reappears. So we are going to open the PDU and then examine the MAC address. So open that with me if you're doing that instantly. So you notice that we have the MAC address of both the source and the destination. So the question we have is, does the MAC addresses of the source and destination align with their IP addresses? Yes, it does. So you can see for here, the MAC address for the source and the IP address correlates, and also that of the destination MAC address and the destination IP address aligns. Okay, so the answer is yes. In B, it says click 172.16.31.2 and enter the ARP space -A command. Remember, you need to switch back to the real-time mode and ping, okay? So leave the simulation mode, come back to the real-time mode, and once you're there, we are going to click on .2, which is here, and type ARP space -A. Okay, so to what IP address does the MAC address entry correspond? So if you look that, you're going to see 172.16.31.3. So that's what we have here if you look at this. Okay, so you can see the answer here. We have another question, and that question is, in general, when does an end device issue an ARP request? Okay, so I'll say that an end device issue an ARP request when it doesn't know the MAC address of the destination. That means the receiver. Step 3, we need to generate additional traffic to populate the switch MAC address table. Okay, so 3A says from 172.16.31.2, we need to enter the ping 172.16.31.4 command. Okay, so let's do that together. 172.16.31.4. Now, when we ping that, you try to get the information, and then it says we need to click 10.10.10.2 and open the command prompt, and then we are going to ping 10.10.10.3. So let's do that. Where can we get 10.10.10.2 over here? And for .3 over here. So we need to ping .3, go to the desktop, go to command prompt, and ping 10.10.10.3. So we have ping 10.10.10.3. Now, we have a question. How many replies were sent and received? How many can you see from yours? For mine, I can see 4 sent, 4 received. Is it the same with yours? So let's go over to step 4. Step 4 says, examine the MAC address table on the switches. Click switch 1 and then the CLI tab. Enter the show MAC address table command. And we have a question here, which is, do the entries correspond to those in the table above? Okay, so let's do what is expected of us here. So we are going to click switch 1 and go to CLI tab. So for us to enter the show MAC address table command, it is expected for us to get to the privilege exec mode. And now we are the user exec mode. We need to type EN to get to the privilege exec mode. And then we'll type show MAC address table. Click enter. So you're going to get this information about the MAC address table. So it asks, does the entry correspond to the table above? So for us to answer that, we'll go over to what we have in the table. So look at the MAC address you have. Let me take the last 4 digits, 8D75. We can see that, and it is fast Ethernet 0/3. We have 8901 gigabytes 0/1. And the fast Ethernet 0/1, we have 1DA. So if you look here, from what we have, you can see the same information here. So what does that tell you? So that tells us that the information is correct. So yes, it does. Switch 1 connected to router 1. So we can see the information there. Okay, so the next one, switch 0. Then the CLI tab, show MAC address table. Do the same for switch 0, EN, show MAC address table. Okay, so does it correspond? If you look here, it does. Going over here, it does. And going over here, it does. Okay, so it's correct. Okay, so let's move over to the next one, and that will be still part of step 4B. So let's look at the next question we have here, which is, why are 2 MAC addresses associated with 1 port? Okay, so we have 2 MAC addresses associated with 1 port, F0/2, because they are connected to the access point. So have a look here. In the access point, we have 1 port, F0/2, and which you can see on the table. So this. Okay, and that is through the access point. So let's see part 2. Examine the ARP process in remote communication. Now, this is the local communication. Now we want to move over to the remote communication. So we are going to click on that 2 and ping 10.10.10.1. So let's do that together. So we'll be able to ping 10.10.10.1. And we can see the packet information. The next thing we are asked to do is to type ARP space -A. Now you can see what we have here. The ARP table can be found here. Now, what is the IP address of the new ARP table entry? Now, if you follow me through what we have here, you can see that there was a time we pinged 172.16.31.3. So the ARP table will add that. And also at this point, we also ping .4, of which the ARP will also add that to its table. Now we are asked, what is the IP address of the new ARP table entry? Now, what do you think it will be? Having said that .3 and .4 has been initially added, you can now see that the new one we have is .1. So we will say that that is the IP address of the new ARP table entry. So you can see the answer here, 172.16.31.1. Now let's move to D. Enter ARP space -D to clear the ARP table and switch to simulation mode. So we are asked to clear this ARP table. And if we want to clear, we have ARP space -D. And once we are done clearing, we move to the simulation mode, which is here. Now we are going to repeat our ping, which is .10.10.10.1. We are going to repeat our ping of 10.10.10.1. 10.10.10.1. Now, if you notice, when you do that ping, you're going to see two PDUs over here. Hover around it, and then you can know the type of PDUs. The yellow is the ICMP, while the green PDU is the ARP. So I don't know what color you have at your own end. Now, the next thing we are asked is click capture or forward, click the PDU that is now at switch 1. Now we have a question. What is the target destination IP destination address of the ARP request? So we have the PDU at S switch 1. Now we are going to check the destination IP address. The destination IP address you can see here is 172.16.31.1. Okay, so now we are asked, the destination IP address is not 10.10.10.1. So why? The destination IP address is not 10.10.10.1. Rather, as you can see here, it was 172.16.31.1 because the gateway address of the router interface is stored in the IP version 4 configuration of the host. And since the receiving host is not in the same network, the host uses the ARP process to determine a MAC address for the router interface, serving as the gateway. Okay. So let's go to step 2. In step 2, we need to examine the ARP table on router 1. So switch to read time. We'll go to read time. Click router 1 and then click CLI tab. So let's go to CLI. Enter key. And let's look at the instruction. It says get to the privilege mode and then the show MAC address table command. So take note of the dash we have there. EN to get to the privilege mode, and then we'll say show MAC address table. Enter key. Now, what do you notice? How many MAC addresses are in the table and why? Can you see any information on the MAC address table? No, there's no MAC addresses here in this table. And why? Now, if you recall, the show MAC address table, that is for the switch. So the router works in the layer 3, which is the network layer of the OSI model, which is to tell us about the IP address of the devices connected to it. So it doesn't build any MAC address table, and that is why we don't have any information about the MAC address table on the router. So let's enter the show ARP command. Is there an entry for 172.16.31.2? Let's see. So we're going to type show ARP. And that will do that. Did you find any entry? 172.16.31.2? Yes, it's found here. So the answer will be yes. So let's move to the next thing. It says, what happens to the first ping in a situation where the router responds to the ARP request? Now, to better explain this, please pay attention to this answer. The first reply will show request timeout. Now, how do you understand this? It says first ping in a situation where the router responds to the ARP. So I just want to give you an example for you to better understand this last question. For instance, if you realize in the instruction or what you've done so far in this lab exercise, I want us to try pinging 10.10.3 for the first time from 172.16.31.2. You can see that we've not pinged that IP before. So for the first time, let's see the response we are going to get. So ping 10.10.10.2. Now, when you ping it, what can you see? Now, for the first time, did you see this? When 172.16.31.2 pinged 10.10.10.2 for the first time, it's going to have request timeout. So this is why I said that for every first ping in a situation where the router responds to the ARP request, we are going to have request timeout, and I have put the screenshot of the same thing I am explaining to you here. So we've gotten to the end of this lab exercise, which covers examining the ARP table, and I hope you've enjoyed every details of the content. Thanks for staying to the end. Don't forget to like, to subscribe, and to also share. And lastly, hit the notification bell so that you get notified when I upload a new content. I'll be signing off now. Do have a nice time. Enjoy. Bye.